Okay, so I finished prior to the break on playing with accessible resources. So that was sort of my first usual approach. When I'm looking at these sort of things, that's one of the first sort of areas I'll go looking for. What can I do without any other sort of security, any other sort of reverse engineering requirement? So now I started to go sort of more into the actual guts of Internet Explorer and some of the actual features of the sandbox itself, see if I can actually break it that way. And the easiest one to go after at this point is the elevation policy. The elevation policy is there to effectively circumvent the sandbox, and that's kind of how it's built in. And the security is effectively only as secure as the worst third-party piece of code which you're going to install on your operating system. So if you install Java, for example, some of Java's, in order to support its plugin architecture and WebStart architecture, it will actually register in the elevation policy and potentially allow you to run arbitrary, fully privileged Java code as long as someone's installed Java. Even Microsoft get on in the act. You could argue Office is sort of third party relative to the IE and Windows team. So all, in current versions of 2013 Office, all Office suite applications are registered in the elevation policy. And obviously you can imagine the sort of potential for fun you could have with something like that. And even Google seems to register, for whatever reason, the Google Updater service and allows you out of the elevation policy as well. I have no idea why, but it does. But of course, we kind of just want to look at default applications, because if you're finding a sandbox escape, you kind of want the most coverage, I suppose, the most available systems to exploit. And there's been various vulnerabilities found in this sort of area before. So let's have a look at the elevation policy itself. So I've got a little tool which we can run up to just basically read the elevation policy from the registry and dump it to the console. So real simple. You can filter on sort of policy type, but so we'll go for anything which will run with no prompting whatsoever. That's all we want. And we'll just dump processes as well. So this will dump, effectively, any executable we can run in the sandbox at medium integrity, the user level, and they'll have no prompting whatsoever. The user has no way of stopping it. And you can see there's quite a few in there. So Amazon generally on this machine has registered itself to allow me to download their music, which is kind of awesome. You can see Office and Flash Broker and Acrobat PDF exposed, awesome. How could running arbitrary PDFs ever go wrong in any way? So yeah, there's obviously Notepad as well, because if you can find a vulnerability in Notepad, I'll be really, really impressed, but you never know, it could be vulnerable. Right. So you can take that sort of list and you can start playing. You can easily just run these applications at this point. You can just kind of run them, pass arbitrary command line, see what happens. But there's actually more to it than that. So it turns out that the elevation policy is not just what processes can we directly create. There is a potential that any of these processes also host COM objects, because these executables could be COM servers. They could be registered in the registry, and potentially, not only can you access directly executables and their command lines, you can also access the COM objects they implement. And I'm not sure, this is by design effectively, but I'm not sure even like the developers of Windows and things like Media Player appreciate that this is possible. Because for example, if I bring up this tool, so I just got a tool I wrote which was for playing around with COM objects, and there's an option to sort of dump anything in the elevation policy. So obviously anything from Office potentially is vulnerable. But for example, Media Player, is registered because you may want to pop media player and runner and play an audio file. But it has COM objects registered against it. So I'm not sure media player's developers realize that I can access the media player burn audio CD handler. I don't know whether it's vulnerable to anything, but I'm sure it wasn't by design. So this came in when I started looking for vulnerabilities. There wasn't much in the, I'm sure there probably still is bugs, but I couldn't find anything too interesting in the default applications installed as part of the elevation policy in a default version of Windows. So I started looking at the COM implementations I could get to from any of those executables. And the one I found fairly quickly was to do with .NET. And if anyone knows any of my previous research, I tend to have a bit of a bias towards hacking .NET because it's kind of easy, it's kind of fun, usually exposes interesting logical vulnerabilities, and so I thought I'd go against it. Now the trouble with this, and I usually take the view that an effective sandbox escape shouldn't prompt the user, because otherwise there's various different ways of prompting a user to do something stupid. You can get them to just say, can you run this executable for me? Sure, why not? And if they click yes, they're stupid, but unfortunately they're users and they will do stupid things like that. So by default, the .NET deployment service, which is installed by default in Windows, will prompt you whenever you're trying to run one of these .NET click once applications, and this is what it's used for. So we don't want a prompt, so we need a way of getting around that. So it's easy enough to create. Just create the process, connect to its COM object, and it's being a .NET application, we can just see what it implements. And this is just using Reflector. I could take the executable binary, stick it in Reflector, and get effectively like C# source code out of it. But after a bit of playing around, there was nothing immediately obvious I could do with this. I'm sure there is a way again, but most of the directions you're going to take are going to end up back at the same prompt, which was kind of pointless. So the nice thing about COM is that multiple interfaces implementation I mentioned in the first session. Each COM class can potentially implement multiple different interfaces, different ways of viewing that object, different functions you can call on that object. And .NET's implementation of COM is no different. And it turns out that there was a very interesting interface on there, the underscore object interface, which looks something like this. And if you have ever done any C# programming, or probably even Java programming, you may recognize this as the sort of basic implementation of the object class, the root of all the inheritance hierarchy. It has the usual toString, equals, all that sort of stuff. And there's two very interesting functions. The first one is equals. And the reason equals is interesting is you can pass arbitrary objects to it. That's kind of cool, because it's a variant. And variant's a COM way of passing arbitrary data to a function. But the one which really caught my eye is getType. And getType is a function, as probably unsurprisingly, returns you a type object. And the type object is a window into the .NET reflection APIs. Now, reflection APIs are mechanisms to inspect and manipulate the running state of a .NET application at runtime. So you can, for example, invoke methods by name, for example. So you can use this to late bind to objects, or you can use this to access internal properties you would not normally be able to write in C#. But of course, in this case, if we're exposing it over COM, I can take a type object and use that to pivot to call any arbitrary function in .NET. So if I can get that type object, maybe I can do something nice. And it turns out to be the case. You can easily write up a piece of code which looks up like the process class and calls start and runs calc. It's very simple. And this turns out actually to a potentially generic issue. It's not necessarily just a privilege escalation issue. DCOM can be run over networks. It's distributed COM. It's designed to be run either between privilege levels on the same box or remotely, so TCP connections or HTTP connections So theoretically, if you could find some sort of enterprise COM object which implemented, which exposed its COM interface over the internet, you could get it and do remote code execution against it, which is kind of cool. So it's easy enough to demo. And I have to shut it down again. Awesome. Where are we? I think we've lost. All right. Yeah, okay. So this obviously works in protected mode, but it also works in enhanced protected mode because the elevation policy doesn't care. It doesn't actually make a difference what sandbox mode it's running in. It just allows you to stick stuff in the elevation policy and run them, which is kind of dumb, really. So I also wrote a generic tool for this. So you can find this on my GitHub page. So you can use it against any .NET COM object you can instantiate and talk to. So it's actually sort of a really simple sort of way of demonstrating without all the sandboxy stuff. And if you could find this enterprise COM object, this mythical enterprise COM object, you could potentially use that to exploit it. So we've just got the usual stuff, 2580 and the 140257. So usual stuff, and so we see it's running up, and we should, I think, still see the df service executable. Oh no, it's actually gone down. So usually the processes will try to shut themselves down when you release all COM object references, but because we've gone through, it's done the type information, it's basically spawned a copy of calculator running at medium, and that's because the executable is running at a higher privilege, and at that point you can do anything you like. Okay. So you could go on forever looking at broker objects. There's a lot of COM objects you can expose through that mechanism. There's still all the third-party stuff if you're looking at that. So my next sort of general approach was to sort of actually start digging into the stuff which required me to do proper reverse engineering this sort of this code. And the best place to start, I felt, was the broker, because the broker is that main window into the IE sandbox. It's the main window. It should be the thing which is directly secured. It shouldn't do anything untrusted, do anything too stupid, because obviously then there's a direct security vulnerability. And most of the broker interface itself, which we try to extract in the first half, is just related to those compatibility shims, those functions which are there to just implement create process, co-create instance, all those sort of things to stop old extensions completely breaking the minute they actually try to do anything. But there is one function on there which is not directly used by anything else, and this is the create known object function. And it basically, again, as the name suggests, will allow you to create certain known COM objects. And you can trawl through the reverse, like it's in IDA, and actually work out all these objects you can create. And you can then go and reference them and look them up and try and find anything interesting. And there's at least 6. I think there's a few more. There's like variants of the same one, and there's lots of sort of crazy stuff in there. So the main reason I wrote my little script to dump the interface is because one of the first things I saw was this shell document view broker. The interface contains around 145 functions. Now that's far too many functions to be manually typing into anything. So obviously I wrote a little quick script to dump it. And in my opinion, 145 functions just seems 140 odd too many to be a secure object. And it turns out that there was various security issues in that. But I thought I'd go for something else because it was a slightly smaller attack surface. Instead of 145, I only had 60 to worry about. That's certainly fewer functions, at least. And this was the IE recovery store. So what happens in modern versions of IE, it sort of stores your browsing history so that if your browser crashes, God forbid, like your remote code execution failed, you can come back to that same page and it will know where you were and it will know what your history was. And it uses, underneath the hood, some other sort of COM infrastructure, the structured storage infrastructure, to actually store these sort of recovery store, these lists of your history and your tabs, and uses that and exposes an interface to allow you to do something with that. And it turns out, obviously, one of the enemies of security is overcomplication. And these interfaces, things like the storage APIs, the structured storage, were not sort of designed necessarily in the for secure access from multiple privilege levels. So it turns out, over the many years of which this code has been developed, interesting functionality is being introduced into that code to do certain things. Because someone went, I really need to be able to use this as a dictionary, not just as a structured storage object. Okay, cool, we'll effectively add like a dictionary type interface to it. And we can get to that interface quite easily. So it all sort of revolves around this sort of, so the iProperty bag is its dictionary type interface. There's actually a different one, there's an iProperty store. Why you have two is probably for some sort of legacy reasons. But it supports things like object serialization. And this got me thinking, what if I could exploit this mechanism? Could I effectively push an object up to the medium level process, a COM object, and get it serialized so that when I read it back, it actually didn't exist in my process anymore. It actually now existed in the higher level process. So that's what after playing around for a bit, I found a way of doing that. So effectively, it's sort of, this particular attack works like this. And if you can find something which has a similar asymmetry in the way in which it's doing things like serialization, you can potentially use this to sort of inject objects into higher privileged processes and do naughty things with them. So there's a function which is just called create storage, which returns a storage object, but that storage object sits in the higher privileged process. And that's returned to you. It's not returned to you directly. What it does is it returns you a remoting DCOM reference. So effectively, you can talk to it, but it's still, the code still sits in this higher privileged process. We can now push I noted that XML documents were serializable, and we can push one of those up to the storage. It will serialize it with a known document, and it will end up now as a binary blob in that storage object, because that's what it's doing. It's storing binary data. Now if I actually say, hey, can you give me that document back? I really need it now. Wait, it does, but now the document ends up being created in the higher privileged process, because it's just a binary stream at this point. It's just a blob set of bits. So it has to go, okay, in order to give this back to you, I need to create this document. So it calls co-create instance and creates the document for you, and then deserializes it and passes you back now a Marshall reference, which isn't the original thing. It doesn't re-serialize it back to you, which it could do theoretically, but it doesn't. So you've got this asymmetry there. And now you've got a document which, the lovely thing about Microsoft's XML COM implementation, it allows you to run arbitrary JavaScript with full permissions in a document. That's great, because then I can just run arbitrary JavaScript to popcalc or whatever I need to do. So I kind of called it object teleportation. It's just stupid bullshit name, but there we go. Okay, so we should have, if I just breakpoint on this, what have we got? So 1778, TV 2014, 1178, exploit thread. And so all this source code is available for you to play with at your leisure. One 778. I think I probably typed it. Yeah. Help if I typed it correctly, wouldn't it? 1778. Okay. And so obviously now we can play around and we get, it's quite a long actual exploit. It's not the shortest piece of code. It has to do a lot of crazy stuff. It has to create storage objects and all that sort of stuff. But there's a key at one point. We create our storage. We then do our serialization. We push our XML document up to the higher privilege process and get rid of it because we don't need it anymore. And then we ask for it back. And eventually, now because it's all remotable, and the nice thing about COM, there's a lot of remotable interfaces. You have to usually implement a specific interface to allow it to be used between processes. But things like XML DOM document implement standard interfaces. For example, iDispatch, which is a way of doing late binding in COM objects. So as long as you can get to iDispatch, at the very least, you can do whatever you like. It doesn't matter at that point. So we read it back, and then we load up a style sheet, which is where we'll run our arbitrary JavaScript. And if we run that, we now see calc pops up. And yeah. Cool. So there's plenty of attack surface already. There's not a lack of attack surface, realistically, but we obviously want to do a bit further. So one of the things I obviously hinted at with the .NET stuff is you can call query interface and you can get access to other interfaces for an object. Now, okay, for say .NET, you kind of assume it's a multi-purpose framework. It's going to have other ways of calling into that object because it may need to support other scenarios. But one of the things I didn't really sort of think about was what about the broker itself? You've got this broker. It's implemented in COM, obviously, and it has query interface because it has to, because that's part of how COM works. But I wasn't necessarily assuming that if you've got a broker, presumably the broker's the only thing you need to do is that's its job. It turns out that if you actually go and look at it, it implements a few more interfaces which you can expand your attack surface to. So obviously the IE user broker, yeah, well that makes sense. The IE reg helper, which is related to handling registry keys. That sounds probably quite dangerous, but there was nothing obvious I could find in that when I was playing around. And in this case, once you've identified that attack surface, you just have a look and see if you can find anything cool. There's various other ones, but I thought I'd go after the ActiveX install broker, which is it's not a typo. It is actually a broker to get you access to the ActiveX install broker. I'm sure there's probably a triple broker somewhere for something, sort of Inception style. Yeah, we can create it, and turns out we can even get. You can even use in UAC mode. So if someone's disabled UAC, you can automatically get access at high. So you can go from low privilege to full privilege with no prompting, which is kind of cool. But in this case, it's default install. UAC is already on, so we're not going to get anywhere that way. But fortunately, it gives us a user level broker. So this runs as normal user permissions, and there is no prompt involved in that. And once again, I went through the same process I've done before, taking the public symbols, and then just extracting those out into C++ structure files, which I can then call and interface with, and try and work out how it actually works. And the installer was actually quite a complex piece of code. There was a lot of sort of interactions. There was sort of a state model in there. You had to sort of call the right functions in the right order with the right parameters, otherwise it doesn't work. So you get sort of a scenario like that, and you could, if you were really, really insane, sit there and in IDA and reverse engineer the entire thing and work out how to do it. I didn't have that amount of time, so what I did was I just run a debugger. So you just set WinDebug, attach breakpoints to all the functions, and then actually do what it's supposed to do, install an ActiveX object. And I ran through and recorded all the function calls as it goes through, what parameters were being passed, which I knew relative to what was in the IDA database, and actually just sort of saying, okay, these are the sequence of operations I need to call to do a normal install. That's great. But there was a problem, and the problem was prompting again, because clearly, if you could just tell IE to install an ActiveX control from the internet, and it did it silently, that might have security implications. So there is a prompt. If you try and do this normally, it will actually give you this prompt, as I've shown there. And it tells you whether it's signed, who signed it, what the name of the control is, and do you want to run it or not? And don't run is obviously the default, so you can't just hit enter and accidentally run it. I didn't want a prompt. So using my sequence of operations isn't going to get me very far. But it turns out that the way in which it verifies whether it needs to prompt you was slightly lacking in its implementation. It turns out there was two parameters I managed to identify. Based on when I pushed it through, I could see these parameters being passed, and I could then infer what their purpose was. And the first one is code base, and the code base defines where this piece of code came from. So effectively, if it came from the internet, it will be a HTTP URL. If it came from a local file, it will be a file URL, or just a file path directly. And then secondly, was the cab file we downloaded for the ActiveX control marked with a low integrity. Whenever a low integrity process creates a file, it automatically gains that integrity level. So it can use this to determine whether a low privileged Sandbox process has written this file, and therefore it shouldn't be trusted and will prompt on it. But there was nothing stopping me passing some local file as both the code base and the path. So I passed calc twice in the code base and the path, and it verified fine, and it bypassed my prompt. That's great. But I still need to then run code, because now, okay, I could probably run calc. That's a fairly easy demonstration, but obviously I didn't want to run calc. I wanted to be able to do something more interesting. So I sort of worked back and went back to my list of operations and found that there was a point where you could do multiple things. You could either install the cab file, which actually required you to unpack the cab file and do some interesting stuff, or you could just register. You could just run the executable. So once it verified this file and you'd done something with it, you could register it, which effectively meant I'm going to run that executable file. But you couldn't pass any arguments to it. And having no arguments, if you're going to try and exploit a local executable, is fairly, is not quite so easy. So I needed a way of injecting arguments. Unfortunately for me, the implementation was slightly flawed, only a tiny bit. And they were not checking that the path was canonicalized. So they weren't joining up these dots. So you could effectively do a double quote injection. So double quotes are not legal file name characters in Windows. You can't technically create a file with a double quote in. But that's not to stop you putting a double quote in a path, as long as the actual final path you try and read or write no longer has that quote. So if you put in a double quote and then put ... after it, effectively that double quote goes away. But the code was taking the entire path and not removing those ... slashes. So you can get your double quote in there and then effectively just inject command line arguments, run an arbitrary executable at this point, and no one's any the wiser, and you can just bypass it that way. So obviously that is now fixed. But you can sort of see if you take, my general approach in this is to take that sort of, what does it do normally? How can I then subvert that process flow, those sort of, because this is multiple different functions interacting to achieve a certain end goal. So it's not just you see that one function in the broker and go, right, I know I can exploit that. You kind of sometimes have to train them up together so you actually get the desired result. So obviously I can demo that one. So I should just still have this running. So get rid of him. And yeah, so you can easily sort of hopefully do this yourself when you get the time. Go away. So yeah, it's just, again, this is actually a relatively simple one. You just create the broker and then just follow the script effectively. Follow the function calls. And eventually you end up with, I verify, in this case I verify Notepad, because obviously I wanted to pop calc, and if I verified calc, it wouldn't look much of a vulnerability, so obviously I had to verify Notepad first, and then pop calc. And you can obviously inject your arbitrary command line there, and it should just run up and pop calc. So yeah, easy enough. Okay, so it turns out my timing is slightly off. I think I've got half an hour left. So I could potentially try and find a 0-day live on stage, maybe. I don't know how well that will work. I can't guarantee anything, so you're quite welcome to go now, but I can see what I can come up with. If people want me to try and do that? Yeah. Okay, fair enough. So let's just pick one which I know should, because obviously my main machine and not my VM it should be fully up to date. So that's that one. Okay, so this is the ActiveX broker one, and there should be somewhere in here. So I've provided like a in the sample code as an interfaces.h file, and this is some of my extracted interfaces. So the stuff I've gone in, pulled them out of the public symbols, and actually tried to exploit. And sometimes unfortunately, public symbols don't have full type information, so sometimes you can't actually get all the stuff out there, but you can usually stub stuff out. You can stick bare pointers in there when you don't know the type of the structure. So we've got the installer there. No. I want to try and find the broker. So wherever it is, I seem to have lost shell document view broker. Okay, here we are. So the 145 functions of shell document view broker there must be something hiding in there, you would hope. So let's see what we can kind of come up with. So there's certainly set as background. Could I potentially, presumably that's for setting someone's desktop background. Could I at least 0-day them by spoofing their desktop background? I'm not sure that's much of an exploit, but you never know. Maybe if you could get some sort of JPEG exploit as well, combine it up, then you could get out that way. It's worth a go. Let's see what it actually does when I try and call that function. Okay. So we'll just, for simplicity reasons, I'm just going to batter over one of the existing ones because that's just far simpler. Do set background. Okay. So we automatically get a copy of the broker. We don't have to worry about that. And it should all just be sample code for this. And so broker, what was it? Set background, set as background. Okay. Oh, that's because I'm clearly an idiot. I'm looking at the wrong one. Yeah, that's the IE broker, which obviously doesn't have the stuff in. This one. Okay. So this was actually a vulnerability I didn't talk about. Basically, you could get it to register files to create, which would just run without prompting. So if you had Java installed, you can actually just get jar files to run. You could point IE at a jar file, it would download the jar file and just run it for you by just calling one of these functions. So we just want this thing. All right. Okay. Doc view set as background. And so we can obviously just sort of go, we'll try test.bitmap. I'm not expecting it to work, but and we'll just print out the result of that, because obviously we need to kind of have a rough idea of whether it succeeded or it failed. Okay. And obviously one thing here is I need to make sure I'm running 64-bit, because my VM was 32-bit, so this needs to be 64-bit, obviously. 268, okay. Okay. That's a lot of spam coming from something. Awesome. No idea what that is. 288. Where are we? Sorry about this. You can't see much of a debug output if something's just throwing rubbish at it. 288. Oh, of course it is. It's VirtualBox. Awesome. Thanks, VirtualBox. Idiots. I'll just kill VirtualBox, it'll be fine. Hey, okay. Right. So yeah, I'm just using debug view from sysinternals, which will capture all the debug output information. And we can just run this. Get rid of him. Yes, go away. Okay, fine, don't go away. .2808. Okay. .2808, and we go for him. Obviously, I can't write proper code. Unfortunately, that crash is probably not exploitable, because it's probably my code, which is a shame. That's because Microsoft may have changed code and no longer can expose this function to you. That'd be an interesting one. Well, I think we're maybe at an impasse on that one, I'm afraid. Looks like something's changed under the hood in the latest version of IE, because these interfaces are internal. They're not supposed to be exposed to user code. Microsoft keep changing the associated GUID with these interfaces. So you usually pass a specific GUID which says this is this particular interface, and it turns out that they seem to have changed it, and it no longer exists. So unfortunately, I think I probably can't easily continue on that one, I'm afraid. Yeah, well, if anyone's got any further questions they want to ask me on this, or anything else they want me to show you, because there's a bit of extra time left. Yes, the question was all the demos patched? Yes, unfortunately they're all patched, or fortunately, depending on how you look at it. There's none of those demonstrations I've got up there will work on a modern version of IE11, fully patched. I'm afraid. Okay, well, that's it. Thanks very much for staying with me.